that'll be the ones where they've put in a wrong substitution, or they've maybe just rearranged the formula wrong. So it's not really fundamentally wrong physics in it, but should they have been given a mark for that question, because they've made that small mistake early on, they would have really got no marks for it. So by colour coding it, it gives them actually a lot more information.
Okay. Then it goes back to question 4, that's fine, and that's interesting because you have used the principle that you were supposed to use there, but you've used it correctly there.
Yeah.
So, as just interpreting it from the
Questions for green for fine, orange for mostly fine, a few details are red for we need to discuss it. So it means that when they have their paper, they can see easily where they're where they're heading with it. And it means also that when I sit and go through it with them, it's really clear to me which ones I need to discuss with them and why.
Over here with question 3, asks you to find the potential energy. You have made a classic mistake with substituting the radius. You have put in the height of the Earth as the total radius. So you've formula right, all the substitution on the top is right. We've just forgotten to add all this extra radius over here. Okay.
Because there's not time for me to mark and discuss with them when we do the very final section test, then what they do at that point is they mark each other's, but modelling what I have done. So they mark it orange, red and green, and then they talk through with each other using the same model as I have shown them as we've gone through, what their areas of weakness are, what they need to do to improve.
I got a lot of oranges. Yeah, you got a lot of oranges. You've done it much different ways from what they've done in there. Sometimes you still got the right thing, but...
You've got into that bit.
Like when you've done the formula change, your formula and that's right, but for some reason you haven't got the correct answer.
That are completely right.
And that was your chance by 10.
He sets himself up in jail.
No, that's just...
I suppose you quite like the method. Like
it was possible. I mean, the advanced higher class, I acknowledge, is a smaller class, so it was easier to find the time. But with the higher class, it was a case of careful management to say, right, in this period I'm going to speak to these 4 next. So I wouldn't try to speak to everyone within one period. I'd spread it over maybe a series of a week or so. But each, the spacing between doing these types of assessments is 4 or 5 weeks anyway. So you have got that time within that period to address the issues with them. So here now, this is the back to the section tests. What these pupils are doing now is they have their own test, they have the question paper and they have the mark scheme. And then what they're doing is they're going through, looking at the details and retrying questions.
Okay, question 2. I've got 4 vehicles plus or minus. V equals plus or minus A squared minus and half and A squared. So if you square out V, you get that.
One of my concerns about advanced higher is that the bank of questions that they are exposed to is extremely limited in comparison to higher.
Right.
So for advanced higher, for example, we don't have an A-B test. They do a NAM at the end of the topic and that's it, and then they do the prelim. One of the advantages to doing this now with all of the section tests in front of them is they can be looking for general patterns in the mistakes. So it should, hopefully it should be the same kinds of things coming up that they can say, right, this is an issue that I need to address, which is not necessarily obvious when you're just looking at one assessment.
Yes.
Task.
Right, okay.
This is a different task. This is use of cooperative learning to address kind of course questions. So in this case, it's exam questions that they're working on. So they have each group has had a exam question that they are responsible for finding the answer to together, agreeing what they think the answer is, and then coming to the board to explain it to the rest of the class. With the interaction of other pupils from other groups asking questions to make sure that everyone then understands the question. The idea being that by the end of the period there, we've all had an understanding of 3 different questions, rather than just spending the time working through 1.5 and not being entirely sure if we've got it right or not.
Okay, well, for 5A, for working out the tension, they'll calculate the force applied by the student. When the
So is the amount that the guy pulls the mass down, so it's just 60 millimeters.
The first stage is really you've got to build their confidence in each other and maintain an atmosphere where it's always positive. So the ones who are perceived to be better by some than others, everybody is given an equal forum to speak and everybody's opinion is seen as equally valid. But they have become a lot better at explaining themselves.
Harmonic motion, and what we managed to put together was when an object is displaced from its equilibrium or a rest position and unbalanced.
W equal 6. We'll be travelling, we'll be accelerating at negative 9.8.
It's about moving the pupils away as well, isn't it, from this idea that if you stood at the front and told them it all, then they've done it.
This is a senior class, there's a real opportunity to do that. It'll be much harder to do it with a junior class, find time on one-to-one. But I just have to carefully plan it in as we go through the topic. So I know that when there is an opportunity to sit and talk with them individually whilst others work, I am doing that.
Okay, anything else? Here? No? Any more questions? List of the energy question. Yeah. And it's asking you to calculate the kinetic energy.
Because they've been put into new groups. I just had them introduce themselves in the groups again. It's a thing, you know, the actual Cooperative Learning Academy.
Yeah.
And they have all these apps, you know, it's not cooperative learning unless you've done X, Y and Z. I don't really stick to that.
That's cooperative learning with a capital L and capital C though, as in the brand.
Yes.
As opposed to cooperative learning, the kind of philosophy.
Yes. It does, you know, it's something I had not thought about before, that when they sit in a new group, even though they know those people, they might not have worked closely with.
John, Matthew, Alex, Daniel and Claire, and Hussein, Liam, Owen and Catherine. So what I want you to do now is to move your seats. You will need your pencil, your calculator. So the first thing I would like you to do, now you have introduced yourself for group, arranged yourself for group working, is to introduce yourself to the group and tell the rest of the group about your favourite bit of physics so far and why.
Right, but they just had to introduce themselves and tell everybody what their favourite bit of physics was.
Your task is to solve the questions that are allocated to your group, to be able to go round the class and teach others how to do the questions. So within your time, I want you both to think about the full solution to the question or model answer between the 4 of you or 5 of you. And also how you're going to teach that to other people.
I feel that this is going to be really important for them, life skill, for any place of work that they go into. Working with other people, first of all, to find a solution to something is invaluable, then being able to present that to other people and to be able to justify what you have done when other people are asking you questions because they don't understand.
Impressive.
Yeah, we've got D like smaller D though.
What? No, it's dreadful.
These initial teach each other tasks, if we look at the clips I've done, they have come on since that first stage is they just sit with the others and read to them.
Yeah.
And the others go, look kind of shell-shocked because they read to them at high speed and have a lot of saying, okay, got that, the sort of. But it has become, if you look at the footage now, it's become more.
The trouble here is it's distance and speed that they're using in this. So you can use
pointing out the sort of pitfalls and explaining. And
yeah, and it's more of a sort of, although you guys are presenting this question to us, we are all here involved in finding the answer. You guys have got a head start, we appreciate that, but we're all contributing here.
Right, for this you need to use v squared equals u squared plus 2as accelerate.
It's not, well, it's their job and they haven't done it right sort of attitude. You know, and I think when they go to university and they're faced with tutorials, they will not fall at that hurdle because they're becoming used to having to justify their solutions and their arguments to their peers. Yeah. I think it's important not just to say this is what we're doing. I think it's important to explain to them this is why and really give them the impression that you have thought it through and you know what is going on and what the benefits are going to be for them.